Of what? Basic of real numbers. Yesterday, what discussed? What is real number? What is rational number? What is irrational number? What is terminating? What's non-terminating? What's repeating? What's non-repeating? What's reoccurring? What's non-reoccurring? So today we will discuss about what? What is natural number? What's whole number? What's integers? What is even number? What's odd number? What's composite number? What's prime number? And then from tomorrow we can start fundamental theorem of arithmetics. So to start that we need these. So first we will start from the natural numbers. So you know already, which you know till class 10th whole are real numbers. So natural number what? Natural number are the real number which start from 1. Which start from 1. They're starting from 1 and end with infinity. Going till infinity. And the difference between the two successor and the predecessor is always 1. This is called natural number. So what's natural number? The real number which start from 1 and with infinity, and the difference between the successor numbers and the predecessor number is always 1. If we cannot say this, so then we can say start from this one is like this 1, then 1.1, 1.2, like this we can say. So what are the example of it? This 1, 2, 3, 4, 5, 6, 7, 8, 9 till infinity. Understood? So 2 is the successor of 1 and 1 is what? Predecessor of 2. So what's the difference? 2 minus 1, 1. 3 minus 2, 1. 4 minus 3, 1. 5 minus 4, 1. These are the predecessor of these 2, 3, 4 and 5. And 2, 3, 4, 5 are the successor number of 1, 2, 3 and 4. Understood? It's another definition also possible. What's another definition? You can say the real number. What you can say? The real number which start with 1 and with infinity, which are not in the form of fraction, which are not in the form of decimal, which are not negative, not 0, always positive, then we can say like this. And if we can say like this, the real number which start with 1 and with infinity are the natural number. This is incomplete definition. This is not complete definition. Incomplete definition of natural number. Why? If we can say the real number which start from 1 and end with infinity, so we can say like this 1, 1.1, 1.11, 1, 2, 1.3, so on. But the difference between these two, check one time, 1.1 minus 1 is what? 0.1, which is not equal to 1. So what are natural number which are complete, which found in nature? Okay. So these are natural number what? 1, 2, 3, 4, 5, 6, 7, 8. Again I am telling, it's another definition. You can understand like this. The real number which are not in the form of fraction, not in the form of decimal, not in the form of negative, not 0, which are always positive, but complete. 1, 2, 3, 4, 5, 6, like this. So these are natural numbers. So I think understood. If next questions are coming, if written this 3, 6, 5, 4, 3, 2, Is it a natural number? Yes, it is definitely a natural number. Why? Because it's a complete. It's not negative. It's not in the form of fraction. It's not in the form of decimal. So there are so many examples: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, till infinity. And what about infinity? Infinity is a number we don't know about that, where it lying. So understood, I think, natural number. Then second coming, what's coming? Whole number. If you know about natural number, then directly you can say, if you can add 0 in where? In natural number. In natural number. Then what's it's become? Whole number. Whole number. Look here. Natural number. If this is a natural number, whole number is contained in it. And one more number in it, one more real number in it, that is 0. 0 plus natural number. And if directly you have to tell what's the definition of whole number, then you can say the real number which start from 0, end with infinity, and the difference between the successor number and predecessor number is always 1. Understood? If anybody is saying whole number contain how many number more than a natural number, then your answer is what? 0. Again you can say, if you want to understand in your form, what's whole number? The real number which are complete, not in the form of decimal, not in the form of fraction, not negative, positive, and 0 is known as whole number. So what's example? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, till where? Infinity. Understood? And again the difference between these. 1, 1, 1. And if the difference not 0 between two number, predecessor and successor, it's meaning not, these are not a whole number. So I think understood this definition also. Then third one coming. Third one is what? Integers. What's integers? So what? This is a natural number. Natural number contained in whole number. Whole number contained in integers. What's it? Integers. So I want to tell about integers. What are integers? So what we can say, it is a combination of what? Whole number. Combination of whole number and negative of natural number. Negative of natural number. So what's its meaning? These are the whole number till infinity. And what's the negative of natural number? If you open this bracket, minus sign coming here. So these we can write like this: -1, -2, -3. In this way, minus infinity. Then what's coming? 0, 1, 2, 3, 4, 5, 6, till where? Infinity. Saying integer are the real number, which are the combination meaning sum of what? Whole number and negative of natural number. So it's again divided into 3 parts. Again divides one time. Look here. What is this? Whole number. What is this? Whole number. And what is this? Minus take outs, then 1, 2, 3, till where? Infinity. And what are these? Natural numbers. So that's why I'm saying integers again divide into 3 parts. How many parts? 3 parts. So what you can say? Another definition of integer. You can say the real number which are complete, not in the form of decimal, not in the form of fraction, but they are negative also. 0 also. So understood? And integers divide into 3 parts. Integers divide into 3 parts. So first part is positive integer. Positive integer meaning like this. Positive integer meaning 1, 2, 3, 4, 5, and what? Infinity. But what are these? These are natural number also. What's this? Natural number. So what we can say? Natural number is equal to positive integer. What's positive integers? And one time look, these are the negative integers saying. Negative integer meaning putting negative sign in front of the natural number. So -1, -2, -3, -4, minus infinity, minus take out. So what's coming? 1, 2, 3, 4, 5, 6, till where? Infinity. So what are these? Inside what we can write? Minus of natural number. What's a natural number? So negative integer is equal to negative of natural number. Positive integer is equal to positive of natural number. In this way you can, and 0 which is neither negative nor positive. So integers are divided into 3 parts. Positive integer, that is equal to what? Natural number. Negative integer, that is equal to negative of natural number. And third one is 0. So in this way what we can say? Natural number contained in whole number contained in integers. And this contained in what? Rational number. Yesterday told you the definition of rational number. So what we can say? Natural number contained in whole number contained in integers, and integers is contained in rational number. Its meaning what? Its meaning is this: all natural number are rational number, whole number are rational number, integer are rational number. Understood? But converse need not be true. Converse need not be true. Converse meaning all rational number are natural number. No. 5/3. 5/3. This is a rational number. What's this? Rational number. But this is not a natural number. Why it is not a natural number? It is not complete. It is not complete. So it's not a whole number, not a integer. So that's why I'm saying converse is not true. Converse meaning is this: all rational number are natural number, whole number, integers. So I think you understood now the relationship between. Understood or not? Yesterday told you this is a bag of real number and divide into 2 parts. This is rational number and this is irrational number. So these natural number, whole number, integers lying in this part. So they are not irrational. Understood? So some more definition we will take. So we will discuss, I think, understood. All of you, if anybody is saying to you like this, -7/8, its standard form is this. So is it a natural number? No. Why? It's not complete. Is it a whole number? Not. Whole number also complete. Is it an integer? No. Is it a rational number? Yes, it is a rational number. Why? Because it's satisfying the condition of rational number. Then next topic, next 2-3 more definition. 2-3 more definition. Odd number, even number, composite number. So what's odd number? The real number which are not divisible by 2. Which are not divisible by 2. So example 1, 3, 5, 7. So 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, 21, 23, 25. Out these? Are these natural number? Yes, definitely they are natural number. These are not in the form of fraction, not in the form of decimal, not negative. So what you can say? These are natural number. If definitely they are natural number, definitely they are whole number, definitely they are integer. If integer, what type of integer? Positive integers. So this is saying odd number. What saying? Odd number. The real number which are not divisible by 2. If you can divide them by 2, like this given 3, 6, 5, 4, 3, 7. So is this odd or not? So there are so many methods, but best method is this. This 7 showing it is an odd number. Otherwise, this is we can apply divide by this. 2 1s are 2. How much left? 1. What's coming? 16. 2 8s are 16. 0. What's coming? 5. 2 2s are 4. How much? 1. 2 6s are 12. 1. 2 8s are 16. Remainder 1. So this number 3 6 5 4 3 7 is not divisible by what? 2. So it's a odd number. So what's even number? Which are divisible by 2. Which are divisible by 2. So which are coming in the table of 2. Okay, whose unit digit is what? 0, 2, 4, 6, 8. All are what? Even number. Otherwise, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, which are coming in the table of 2. Or you can say, whose unit digit is what? 0, 2, 4, 6, 8. Unit digit meaning I have written 16. So what's its unit digit? This is its unit digit. So by checking the unit digit, easily you can decide this is even and which is odd. Understood? So next coming, what's coming next? Prime number. Prime number meaning the real number which are divisible by 1 and itself. The real number which are divisible by 1 and itself. Understood? How can like this we have taken 2. It's divisible by 1, divisible by 2. 3. It's divisible by 1, divisible by 3. So these are 2 numbers, 1 and itself. 5, 1, 3, sorry, 1, 5. Understood? 7, 1, 7, 9, 1, 3, 9. So this is not a prime number, but 9 is a odd number. What's number? Odd number. Understood? If anybody is saying, how can you find out prime number? So easily we can say, even number are not prime. Only 2 is that number which is even also and prime also. And if anybody is saying, how many prime number lying between 2 1 200? So easily we can tell 25 line. Here also using one methods. Later on we can discuss. Now our main aim is to start chapter number 1. So this is about prime number. So what we can say? Prime number where contained? Contained in what? Natural number. 2 is the only even number which is prime. Understood? Next coming, what's coming? Composite number. We know what are odd number, we know what are even number, we know what are primes. Then what is composite number? Composite number meaning having more than two factors. Or you can say like prime number, which is divisible by more than two number. Which is divisible by more than two number. What's its meaning? Its meaning all even are composite number. All even number are composite number. But again saying, its converse not true. All composite are not even number. Example 9. 9 divisible by 1, divisible by 3, and divisible by 9. Satisfying this condition. Having more than two factor, it's also more than two factor. What's 1, 3, and 9 itself? So 9 is a odd number, but composite also. That's why I'm saying all even are composite, but all composite are need not be a even number. Now, what you can say? Like this, we have taken 4. So what are the factor of 4? Divisible by 1, divisible by 2, divisible by 4. 6 you can take, divisible by 1, divisible by 2, divisible by 3, divisible by 6. Divisible meaning after finite number of steps, remainder coming 0. Then what's coming? 8. 1, 2, 4, 8. Then what's written? 9, 9. Already I told you. What about 10? 10, check one time. 10 divisible by 1, definitely. Divisible by 2, yes. Divisible by 5, yes. Divisible by 10. So 10 is also a composite number. 11. 11 is a prime number. 11 is a prime number. It's meaning it's not more than two factor. It's not divisible by more than two numbers. It's 11 is divisible by what? 1 and 11. So this is not a composite number. What about 12? 12 is a even number, definitely a composite number. 13. 13. 13 divisible by 1, divisible by 13. No other than it. So this is also not a composite number. 14. 14 again is what? Even number. Even number means definitely a composite number. So use of this composite number in the fundamental theorem of arithmetic. Fundamental of theorem of arithmetic that we can start tomorrow. And in this way we will continue this, our syllabus. So this is all about this. We discussed what we discussed. Natural number, whole number, integers, rational number, irrational number, terminating, non-terminating, then repeating, non-repeating, reoccurring, non-reoccurring, even number, odd number, prime number, and composite number. From tomorrow we can start, what we can start? Fundamental theorem of arithmetic, which is so much important in this chapter. Thank you all of you.